value functions. This is just like modulus, it only has a different technical definition. I've already put roughly the answer up for that one. So just with the definition of it, all right? So look at this. The absolute value of the modulus of x is x if it's positive and negative x if it's negative, all right? The reason we use negative x if x is less than 0, because then you have negative negative, which makes it positive. So we know modulus, we've done it in vectors, we've done it in complex numbers. We know this means just make it positive. What's its size? So these will be easily cranked out, and then we're going to get into the idea of the definition of it. So firstly, given x is minus 2, the modulus of minus 2 is positive 2. All right, we have x is minus 2 take 5. That's the modulus of minus 7, which is positive 7. All right, 2x plus 10, we just need to evaluate that a bit. We've got 2 times minus 2 plus 10. And the modulus of that, minus 4 plus 10. The modulus of positive 6, which is 6. And then, for this one here, 3 take the modulus of x. Well, that's 3 take the modulus of minus 2. That's 3 take 2, which is 1. Okay, let's move on to question 2. And question 2 says, define the following algebraically and graph. So this is what we're given. This is how we're going to define it algebraically. And I want to just make the link so it can really clear between this statement and what I've written there. Okay? If you were to just replace x plus 3 with a or with x, then it's going to read exactly what we have written there. I've got if x modulus of x plus 3 equals x plus 3 if it's greater than 0, and equals negative of x plus 3 if it's less than 0. Okay? We do need to just process this a little bit more though, so we're just literally pulling that from there to match what we have here. The process is just to get x by itself here, which is we're going to have x is greater than minus 3 and x is less than minus 3. Alright, that's what those two statements simplify. Okay, and then it says to graph it. Alright, so what we have here, if we consider that y equals x plus 3, so let's make the statement. It's going to be y equals x plus 3 if x is larger than minus 3. And it's going to be y equals minus x plus 3 if x is less than minus 3. That's the statement that we have here. Right? That's what that means. So when we're going to graph this function, really we've got two graphs that we need to consider. So let's go to the Cartesian plane. And we can use our calculator here to support us as well. Again, in a moment, I'll show you the absolute value button on the calculator. Firstly, we've got when x is greater than minus 3. So I'm going to draw up a Cartesian plane. Here's minus 3. All right, so we're considering when x is greater than minus 3, the equation is y equals x plus 3. Now that's the equation of a line. It has a slope of 1 and a y-intercept of 3. So I'll put the y-intercept up here. And so it's going to be this line. All right? For values greater than 0, that's the equation of the line. For values greater than minus 3, sorry, that's the graph of the line. But then for values less than negative 3, the equation of the line becomes minus x take 3. Doesn't it? If we expand that, that's what it becomes. Minus x take 3. And so this line here, this has a y-intercept of negative 3. So I'm going to plot it there, but we won't draw it. And a slope of negative 1, which means, I'm going to just draw the slope of negative 1, so it's going to be going through that one. It's this line here. Alright? But it only exists for values less than negative 3. Now, of course, this is true. Look, modulus of x plus 3 means positive values of the equation of the line here. So we're not considering negative values of it. All right. If you imagine the line y equals x plus 3, it goes like this, but we've reflected all of the negative values in the positive axis. Okay. So I want us to start thinking about it like that, start trying to draw it ourselves, but we will again use our calculator to help us out. Let's go to this one. We've got the modulus of x plus 2x. So this is a little bit more confusing, but let's write it out using the notation we've given there. So the absolute value of x is going to be, so if we have the modulus of x plus 2x, it's going to be, trying to draw my curve bracket. There we go. Is going to be x plus 2x if x is greater than 0. And it's going to be minus x plus 2x if x is less than 0. Alright, so notice how the modulus only applies to this part, so it's positive for values greater than 0, and negative for values less than 0. The modulus is only applying to that x term. This 2x remains the same. So we can simplify both of those as well. What that means is we're going to graph 3x for x is greater than 0. And we're going to graph minus x plus 2x. We're going to graph x for x is less than 0. Alright, so let's sketch that on the Cartesian plane. I've just done a rough scale. Each line represents 1 unit. Okay, so for values greater than 0, we have a line, this is y equals 3x. That means as x goes across 1, y goes up 3 spaces. Across 1, up 3. Alright, so we've got a very steep line. And then for values less than 0, we have y equals x, which is the equation of the inverse lines in that one. Okay, so that's what the graph of this function is going to look like. Okay, here's how we can access the absolute value button on our calculator. So you can do it in graph, and you can even do it in run map if you want to calculate the modulus of something. What we press option, numeric, and then absolute. Abs. And that's going to bring up the box, and then you put whatever you need to find the absolute value of in there. You can do that in the graph. Splendid. So that's enough to get to 3F1. Stop there.